Hey guys, so the last lesson we have is interpolation and extrapolation. Don't overcomplicate this. Your teachers may go through it a bit, but basically interpolation is, or inter, right, means within, right? So within the data set range, right? So basically, if we have a look at this, right, the data goes from 58 to 84 for females and 55 to 79. All data that is within this data set is interpolated, right? All the range from here to here, right? It's all interpolated data, right? Extrapolated data, on the other hand, extra, right, means outside the data range, right? So, for example, anything that's below this or higher than this. So what makes this important is that, for example, if we are predicting heights, right, or life expectancy, for example, right, in 2010, life expectancy for females was 84, right? So about here, right? If we keep going with this trend, right, and we go outside this range, right, when we get to 2045, we're eventually going to have a life expectancy of I don't know, maybe 130 or something, or 140. And if we keep going to here, we'll have a life expectancy of 200, right? And we just know that you don't have any people, you don't have any no one's going to be 200 years old, and so the reason it's important is because interpolated data, if it has a really strong connection, it's going to be really, really accurate. But when you go outside those bounds, you're going to have less accuracy, and it's not going to be as stable as you might think, right? It's not going to be accurate, right? Even heights, if we had, years here, or age and height, right? Eventually people stop growing. So if we keep going with this trend, you're eventually going to have a 55-year-old who's, 4.8 meters tall, So that's just something to look out for. And yeah, just be aware of. All right. That's it for bivariate data. Hope you enjoyed. Let me know if you have any questions.